need to work on because tomorrow we're going to reassess this area. Okay, that was a standard that we still struggled with, so I want to make sure that we review it again. Okay, so what I need you to do is read the essential question with me. Okay, here's the essential question. Read it with me.
What strategies can we use to find the area of a rectangle? Which strategy is
most efficient? Okay, now with our essential question today, we're going to be able to answer that by the end of the class. But our learning objective, which is what we're going to be able to do today, is the following, and I need you to read it with me, okay? Students will be able to find the area of a rectangle, identify a strategy to find area, use the most efficient strategy, and use multiplication to find the area. Now, that's a lot, right? But believe it or not, it's actually, you're doing it all together as we do our lesson today, okay? So we're going to go ahead and introduce our lesson and think about that this is what you should be able to do. So whenever you get stuck, you should be able to find the area of whatever object, okay? Now, when we talk about area in the real world, right, we talk about how, if we wanted to build something, we needed to know how big the table, how much wood we would need for the top of this table. And we would do that by trying to measure the area, okay? Now, so let's go ahead and look at these two figures here, okay? And the question says, find the area of the blue rectangle, okay? So what are we going to do here? How are we going to start off doing this? Jemiah, what can you do to find the area of the first rectangle?
By multiplying the side length and the width.
Okay, multiplying the side length and the width, okay? So what is the side length?
2.
What is the top length?
3.
And what would it look like?
6.
Or what would our number sentence look like?
2 times 3 equals 6.
Thank you, Jemiah, for raising your hand.
2 times 3 equals 6.
Equals 6. Now, when we talk about area, what's missing here? Because 6 is correct. That's how many squares we have. But when we talk about area, what else do we have to add there? Kevin?
We have to add the units.
Okay, so the units. Okay, but we don't have, we'll put units here because do we know if it's centimeters, inches, or anything like that?
No.
Okay, but we're still missing something when we put units here. What are we missing,
Square.
Morgan?
Square units.
Square units, okay? Now, this one, this second figure, it doesn't have the number of columns and rows. So how would we find the area for this figure? Tony?
We could put a line up there and maybe two.
Come up here and show me what you mean, a line right there.
Right here.
Okay, how about you do it for us? Where do you want to put the line? Because I'm not sure right here and here is not explaining. Oh, okay. So he is only telling us what where the side length would be. Okay. So then what do I do from there? Okay. So what are we going to do with this though? What is the side? What are these lines telling us? That's how long the side length is, right? So what's the side length here, Juana? What's the side length for this one?
6.
The side length.
2.
2, right? Okay, now how are we going to find the top length, Leslie?
We would put the lines just like Tony did.
But where instead?
Over here, guys. Let's go, Vanya.
We did the length of the side length. The width now, right? So we would put it for the width. Now, how are we going to find the width? Joseph? Counting the squares outside the box. So what's the side length width here? 3. Okay. So now, do we need to count the squares on the inside? No. So what information do we have to make sure that we find the area without counting? Yes.
Lassie.
Okay, so we can use the rows and columns. And what are we going to do with those rows and columns? Multiply them together. So what is our number sentence going to look like? 2 times 6, 3. Right? The side length and the top length, which equals what, Michael? 6. 6 what, though?
6 square units.
Okay, now, I'm asking here now, how did you find the area? What strategy did you use to find the area? What strategy did we use? What strategy did we use? Think about it before you call out. Or raise your hand even. Okay? What strategy did we use? Remember, we have posters here to help us out. Which of these strategies did we use to find the area?
Multiply the dimensions.
We multiplied the dimensions. Okay? Here, the strategy we used was multiply the dimension. Was this an efficient strategy? Meaning something that was quick and correct? Yes, this was. Now, what other strategies out there could we have used? Some of us use different strategies, but the one we used as a class was multiplying the dimension. What is another way to double check our work to make sure that this is what the total area is? Morgan? What is the very first strategy you learn when we talk about area? Even before skip counting, but that is a strategy.
Counting.
What is it, Joseph?
Counting.
Counting. We could have counted, right?
Count one by one.
But we've kind of graduated and gotten better from counting that we can just multiply the dimension, right? Now, if the array is even bigger, I do notice that some of us are counting. Now, that's a good strategy, but we want to graduate and get better, evolve into skip counting. We want to get into multiplying the dimensions. Okay, Tony said he counts the side length and the width, and then he multiplies.
To an area of 72.
And then, if Kevin wanted to double check his work, you could have counted every single one. But again, everyone has a different strategy, okay? So, if you look at our learning objectives for today, and I'll wait. If you look at our learning objectives, it says we're going to find the area of the rectangle. Did we find the area of that rectangle? Did we identify a strategy to find the area? What was the strategy we used?
Multiplying the dimensions.
We multiplied the dimensions. Okay. Was that our most efficient, meaning the fastest and the most correct? Yes. Okay. Did we use multiplication to find the area?
Yes.
Yes, we did, right? So it's okay that, for something very small, we should be able to do that, right? But today during our activity, we're going to be creating arrays that allow us to go back through our learning objective and see, did we find the area of the rectangle? Did we find it efficiently, meaning quickly and precise and correct? And did we use multiplication? Now, it's okay to use something different, but we want to evolve into that, okay? So in our small groups, we're going to work on some activities just to review area.
Combine. Very good.
All right. Okay. So I know that our learning objective earlier was really long, so I kind of shortened it so that it's all in one sentence, okay? So the learning objective is students will be able to find the area of a rectangle using the most efficient strategy. So before we even get into being able to do it, let's talk about what efficient means, okay? Efficient. Okay? Efficient means that whatever strategy you use is the quickest, okay? Like you get done, because when we take an assessment or some of sort, or when we do a class assignment, do we have all day? No. Okay, no, we don't, right? We don't have all day to solve the question. So what we try to do is find a strategy that's the most efficient, that's the quickest, but if we do it quickly, we have to make sure that it is correct. Okay? So here we are going to find the area, right? So when we talk about area, what are some key words that we know when we talk about area? And we'll create a word bank. And Ms. Hamilton has talked to some of you about what words are important when we talk about area. So what are some key words that we need to know about area? Yes? Okay, side length. Width. What else? Morgan? Jemiah, I mean? Sorry. What else?
Combined.
Look at your paper. Look at your paper and see what else you need to know.
Area.
Okay, you do need to know the area, right? Because that's what we're trying to what? Find out. We need to find the area. What else? Square units. Perfect. Because that's what we need, right? Or that we use to find the area. Square units. What else? Yes? Dimensions. Okay, that's similar to length and side width. Leslie, anything else? Skip counting is good because you need to know how to, you can use skip counting. Anything else? Anything else? Inches, okay. If that's a unit, you would need to know what an inch is if that's what unit we're using. Okay.
Wait. Skip counting.
We have skip counting. Okay. So now, well, how about we just stop right there, and then if we have anything to add, we can add it. Okay. All right. So I want you to go ahead and do number 1, and I want to see which way do you find the area. How do you find the area? Write down what you're thinking, because I saw you do it, Leslie, but you didn't write anything down.
He combined the two, shaking together what is the total area?
Okay, so Juana, how did you find the area?
I counted the top length, the side length, I counted the area.
Okay, so you counted the top length and the side length, and then what did you do with those numbers?
I skip counted.
You skip counted, okay. What did you skip count by?
4 3 times.
So you skip counted 4 3 times. So you counted the side length and the top length. So
Tony and Joseph, are you guys doing what you're supposed to be doing?
counted the dimensions, and then what else did you do?
Okay, let's go. Once you have it, I want you to look at your shape. First, look at your red one.
What did you do after you counted the side lengths?
Red one.
I added them up.
Added them up?
Multiplied.
You multiply them, right? And then in order to multiply, you had to use skip counting, correct? So counted the dimensions and multiplied them. Okay, good. So that's one strategy. What about you what did you automatically do?
I skip counted.
You just skip counted, right? Okay, good. So that's two strategies that we can use, all right? Now, I want us to stick to those two strategies, all right? Because our objective is to find the most efficient way, okay? These arrays are not that big, but I don't want us taking the time to count every single one of them, all right? So I want you to continue on and find the area for the rest of the examples, okay? Using the strategy you used to start off with. Okay, so if you use skip counting, keep using skip counting. If you multiply the dimensions, keep multiplying the dimensions. And same with you, okay? Because I see you're multiplying the dimensions.